Our topic today is the quadratic formula. So we're going to start with a reminder of what a quadratic equation is. In standard form, it's ax squared plus bx plus c equals 0. So a quadratic equation, remember, is when you can solve for x. It equals 0 as opposed to y or f of x. That would be a quadratic function. Quadratic formula is useful to solve a quadratic equation when it doesn't factor and it's not very easy to complete the square. So remember, the first step in completing the square is to cut that b value in half. So if b is odd, or if the leading coefficient, when you have to divide that out, ends up with a nasty fraction, much easier to just use quadratic formula. Quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's a cute little song for that, but there's no way I'm singing it on the video when you can replay it over and over and make fun of me. So maybe we'll sing it in class when no one's recording. We'll see. And lastly, we're going to take a look at the discriminant, which is the part of the quadratic formula that's under the radical, and that tells us how many real solutions we have, or possibly if we have imaginary solutions. Remember, if there's a negative under the radical, we get an imaginary number. So our essential questions today are, how do you solve a quadratic equation in standard form? And how do you determine the number of solutions for a quadratic equation? So we're first going to practice our quadratic formula. If the equation isn't already set equal to 0 like ours is, you'll want to get it equal to 0. Quadratic formula only works when your equation equals 0. Similar to factoring, when you do your zero product property, if it doesn't multiply to 0, zero product property doesn't work, funny enough. Second step is to identify a, b, and c, because we're going to need to substitute those into our quadratic formula. A, remember, is the coefficient of your x squared term. B is the coefficient of your x term. And c is your constant. Make sure if there's any subtraction that you treat that like a negative sign. And we will substitute into the quadratic formula. I'm running out of room, so I'm actually going to get rid of this so I can extend my page. And then we will always give our answer in simplest radical form. Sometimes with word problems it might make more sense to get a decimal, but for now with practicing we're going to combine some of the skills we've already looked at. So quadratic formula, x equals negative b, or the opposite of b if b is already negative, plus or minus the square root b squared minus 4 times a times c all over 2a. So if you ever do punch all of this into your calculator, make sure in the denominator that you multiply 2 by 8 before you divide. And since you're multiplying by 2, it's going to be fairly easy to do that in your head. Otherwise, if a isn't 1, you're going to end up with the wrong answer. We're not going to do that for now. We're going to find our answer in simplest radical form. So we've got negative 5 plus or minus. I'm going to start simplifying under my radical. 5 squared, of course, is 25. 4 times 14 gives me 56. And I'm adding 56 because I had a negative 4 times a negative 14 all over 2. Adding my like terms, or adding my numbers under the radical, I get 81. And of course, 81 gives us a nice perfect square, so we're going to get integers on this one. What that means is that our original equation actually factored. If you ever get integers when you use the quadratic formula, factoring probably would have been the easier route to solve. So in the numerator, we get negative 5 plus 9 gives us 4 divided by 2. Negative 5 minus 9 gives us negative 14 divided by 2. So we get x equals 2 and x equals negative 7. Next example. I know this video is going to run a little bit long, but I want to keep the same topics together. So first, set your equation equal to 0. Now you can subtract 3x squared from both sides, but I really like keeping my a positive, so I'm going to move my other two terms instead, subtracting the 9x and subtracting the 5. Identify a, b, and c. A is the coefficient of your x squared term. B is the coefficient of your x term, and c is your constant. Again, those subtractions become negatives. Quadratic formula, x equals the opposite of b, so in this case a positive 9, plus or minus the square root, b squared, and I drop the negative because once you square it, it becomes positive anyway, and the negative sign, if you don't use your calculator correctly, can give you the wrong answer. So I just do the absolute value of b squared essentially, minus 4 times a times c all over 2a. All right, and then give your answer in simplest radical form. Now you can just punch everything under the radical into your calculator and get an answer. I don't have my calculator handy, so I'm going to do a little bit of algebra, a little bit of basic math. 4 times 3 gives me 12. Actually, let's do 4 times 5 gives me 20, times 3 gives me 60. And I've got 2 negatives, so it ends up being positive again. Adding my 81 and my 60. And 141 has a factor of 3, so I'm going to do a factor tree real quick. Losing my train of thought. 3 goes into 14, 4 times the 2 left over, there we go. So we've got 3 times 47, 47 is prime, so there is not a perfect square factor of 141, so this is in simplest radical form.